doing problem 2, section 5.1. So this one is asking us to find the critical numbers, find the intervals where the function is increasing and decreasing. So we'll do A, and we'll see how much of B and C we might be able to fit. So the function is 2/3 x cubed minus x squared minus 24x minus 4. Okay, so to find the critical numbers, first of all, remember there's two kinds of critical numbers. For this one, it's a polynomial. They're defined everywhere, and so are their derivatives, so there won't be any of those type 2 critical numbers. That is where the derivative doesn't exist. So really all we're concerned with here is where is the derivative 0. So we take that derivative, power rule, put that 3 in front. It will cancel with the 3 there, so we're going to be left with 2. Lower the power by 1, 2x squared. Same idea here, power rule, 2x, and then minus 24, and the x goes away for a derivative. And then the constant, its derivative is 0. So remember that to find the critical numbers, we want to set this to 0 and factor it. So first of all, let's factor out a 2, since there's a 2 common to everything there. So we'll get that. So we'll set that equal to 0. We'll get, and really the 2 here is not going to matter, because when I set that to 0, there's no x there. 2 is never 0, so basically, or another way you can kind of think of this is, if this thing is set to 0, I divide both sides by 2, well, the right side still stays 0. So really all I'm doing is setting that to 0. That thing factors to be, what is that going to be? X minus 4, looks like x plus 3. Okay, so that if we set those individually equal to 0, we're going to get x equals 4 and x equals negative 3. Okay, and then it says find the open intervals where the function is increasing and decreasing. That's parts B and C. So to do that, remember we set up our table. We get minus infinity up to the smaller of the two critical numbers, so minus 3. Then we go from that critical number to the next one, 4, and then from that critical number to infinity. So we get these 3 intervals, make our table. We want our test values, one test value for each interval, so let's pick minus 4 here. Let's pick 0 and 5. And then we check the sign of the first derivative, and then we draw our conclusions. Excuse me. We draw our conclusions based on the sign of the derivative. Okay, so let's start with 0 here. I think 0 is the easiest number to plug in, although really using the derivative in its factored form is probably the best way to do this. So let's just go ahead and start at minus 4. If I plug minus 4 into this factored form of in fact really better, this one. Oh, yeah, here. If I plug minus 4 in here, notice what happens. I'm going to get minus 4 is minus 8. That number is negative. If I plug negative 4 into there, minus 4 plus 3 is negative 1. That gives 2 negative numbers. So there the derivative is positive. If I plug in 0, I'm going to have a minus 4 times a plus 3. That's a positive number. I'm sorry, that's a negative number. A minus times a plus is a minus, of course. Let me erase that. So that should be negative right there. So negative here, and then if I plug in 5, notice what happens. 5 minus 4 is 1. 5 plus 3 is 8. Both of those are positive, so we're back to positive again. Okay, so our conclusion is that the function is increasing here, and then it's decreasing, and then it's increasing. So to answer our question for part B, where is the function, which one was which? Where is the function increasing? So it's increasing on that interval and also on that interval. So the way we write that is minus infinity up to minus 3. And then a union, and then again from 4 to infinity. Okay, and then for part C, the only part that it's actually decreasing is just right there from minus 3 to 4. So minus 3 to 4, only place that the thing is decreasing. So that answers part A. we'll do parts B and C on the next couple videos.